It is you, the poor Salesforce developer forced to create an integration with GitHub. Luckily, GitHub offers a comprehensive REST API, allowing you to retrieve almost any data you need. The catch? There are countless endpoints, and you often find yourself making a dozen calls just to stitch data together into a single structure with the right dependencies. And sometimes, GitHub REST API simply doesn't have what you're looking for, so you reach out to support with tears in your eyes, asking them to add an endpoint you need. But you know what? You never get it. That's the harsh reality. The real issue here isn't GitHub, it is rather REST API. Aside from overwhelming number of endpoints that you have in REST API, there is always a chance that the exact data, exact endpoint you need just aren't there. This issue isn't unique to GitHub. It really can be any weather API, Shopify, or really any service when you don't have control over the backend. You can just crack open the source code and add what is missing, right? And this is where GraphQL really starts to make sense. Yeah, give you a dislike, leave the comment, 2 videos, you need GraphQL, you don't need GraphQL, what the hell, why should I listen, unsubscribe. Yeah, actually it is for Apex, okay? Apex, some kind of integration with any other API which you don't have control over, makes sense. Keep going. GraphQL provides a single endpoint for all of your queries, where you can specify any complexity of the data you want to retrieve, and what is no less important, you will receive already aggregated data in the format in which you requested it. Also, GraphQL, even though I personally find its query structure kind of weird, in this case GraphQL is easier to maintain, because with the REST API and large number of endpoints, it's really easy to get lost in what you're doing. With GraphQL, it seems like much more easier to understand. And of course, the main benefit and main advantage of the GraphQL is that you can get exactly the data you need. For example, a GitHub REST API endpoint allows you to retrieve all open issues, which is great, but the response includes every field available, even if you only care about a title and body. With GraphQL, you can request just those fields, avoiding overfetching. But here's the twist, my Salesforce developers. How do you even create? So she realized that she actually needs to create this GraphQL query in Apex on her own, which is crazy. So the question is, how do you even create those GraphQL queries in Apex? I mean, potentially those queries might look something like this, which you need to create, properly organize, have some kind of structure, send to the GraphQL endpoint, get a result. Time consuming, painful. I'm not gonna do that, I'm gonna use REST API. Here, I want to talk about our incredible Salesforce community, okay? Because if you open your GitHub, you can easily find such a repository, Apex GraphQL client, a link to which I'll definitely leave in the description, which provides a convenient GraphQL query builder. These are no longer those incomprehensible strings and their concatenations. These are classes, instances, and parameters that you operate on in an object-oriented manner, and which will generate a query for you at the output, which you then simply send to the GraphQL endpoint. This is already a serious argument to consider GraphQL, because in addition to all of those benefits which we talked about earlier, now you have an open source builder to build those GraphQL queries in Apex. So let's see what we can do. To start, let's take this GraphQL structure from GitHub as an example. Here we get a repository called Hello World, owned by the user OctoKid. Then we get the last 10 issues for this repository, and inside the edges and nodes, we specify the fields that we want to get. Also, for each issue, we get the first 10 labels, which have a parent-to-child relationship to the issue. In case of child to parent, you also specify them in the exactly same structure, just change the field name. Pretty clear and simple. But what if we want to specify these conditions right here as or, either the repository Hello World or what is owned by the OctoKid? This is a common confusion when it comes to GraphQL, because we think of it as some kind of database language like SQL, where we specify different conditions and everything works fine. I want you to think of GraphQL more as a method. Let's say you have a method in Apex that takes attributes repository name and owner, and that you call. And obviously you don't specify and you don't pass any conditions. More technically, we call it remote procedure calls. And here you can say that if this were an Apex method, I would add a new field condition where I would specify whether it is or and. You're right, this approach is also possible with GraphQL. When GraphQL is being configured on the backend side, you specify so-called schemes, where theoretically you can determine on how to handle this scenario. But this is not a very popular use case for GraphQL. Nevertheless, let's go back to our GitHub GraphQL query and let's create an identical structure using the open source library. To start, you need to install the package, which is quite simple and quick. After that, let's put it together. Practically speaking, this open source repository revolves around the GraphQL field and GraphQL query classes, which allows you to define fields and nodes and in general build a deeply nested structure. So let's start with the repository field, which is the entry point right here. So we created using the instance of GraphQL field, where the first parameter is the name, in this case repository, followed by a list of fields that are included in the repository, like the deeply nested or just nested fields. And as we can see in the example, we don't actually retrieve any fields of the repository itself, right? We go straight into the associated issues. So we do the same thing here. We create another instance of GraphQL field, passing issues as the first parameter, aka name, and again a list of nested fields as the second. Moving on, we need to create an intermediate edges and node layers, which is right here. So we do the same thing using GraphQL field constructor. Specify the name and then the list of nested fields. Now we have reached the point where we define the actual fields of the issues that we want to retrieve. If a field like title has no more nested fields, meaning it is the last deep, we still use GraphQL field but only specify the name and skip the second parameter at all. So just a name, string, cool. Repeat this one for the next field, and for the third one, aka labels, we have to go deeper because it is related data, and therefore we go like this, and only after that we specify name as the label field. Once the structure is complete, we add arguments to this query using the withArguments method available on the GraphQL field. For example, here the first parameter is the name of the argument, like first here for labels, and the second is the value, like 10. Then for issues, we specify the argument last and with the value of 100. Finally, we set two main arguments for the repository, filtering by owner and name. And at the end, we create an instance of GraphQL query passing in our fully constructed query. We use a list here because theoretically a GraphQL query could include multiple nodes. In other words, you can query two or more unrelated data sets in the same request, as you can see on your screen right here. Now let's check if we did a good job and output the result by using the build method with the true attribute to prettify the result. You can pause here and verify that the generated output structure is identical to what we intended. In the meantime, I'll mention that if this code representation feels kind of hard to follow, which I'm inclined to agree, you're free to organize it however you want. For example, you might prefer building the query from the bottom up so that all field definitions are separated and easier to read. It's completely up to you. Now, if you're asking yourself, what's next? Well, after creating the query, you simply send an HTTP request to retrieve data. That's it. What is great is that this open source client also provides classes to help you not only build GraphQL query, but also send them to a GraphQL server. I'll leave all the relevant links below the video. Lastly, I want to touch on how GraphQL handles errors. Suppose you send a bad GraphQL request. Will it return an HTTP bad request status? Most likely, no. One key difference with GraphQL is that it returns a 200 OK status even for broken queries. Instead of relying on a status code like REST APIs often do, GraphQL doesn't really care about those codes. And the idea it follows is to include either a data result or a list of errors in the HTTP response body. If something went wrong, the errors will contain detailed messages explaining what happened, and then you can decide how to really handle it. But the status code might still be 200 OK status.